Good morning, students of grade 9. Today we are going to solve the second exercise about mechanical action and equilibrium. In this exercise, a block M weighs 25 Newton, rests on an inclined plane when it's joined by a string to a support. As shown in the figure in here, the block M rests on an inclined plane connected to a string, and this string is connected to a support. Use G equal to 10 Newton per kilogram. Given that the force done by the string on the block is 12.5 Newton and the force done by the inclined plane on the block is 21.6 Newton. Part 1. List and classify the forces acting on M. The forces acting on M are three. The first one is the weight force. Its symbol is W and it's an acting from a distance force. The second one is the tension force, which is due to the string. Its symbol is T capital and it's a contact force. The third one is the normal reaction of support force due to the inclined surface the block is resting on it. Its symbol is N capital and it's a contact force. Part 2. Find the characteristics of the forces acting on M. As we said before, to write the characteristics of the forces, we make a simple table containing the three forces we have and the four characteristics for any force we have. Let's start with the weight force. The point of application for the weight force is the center of gravity of the block M, which is this point in here. The line of action of the weight force is vertical, which is always vertical. The direction of the weight force is always vertically downward, and its magnitude is given, which is equal to 25 Newton. The tension force. The point of application of the tension force is the point of contact between the string and the block M, which is this point in here. This point is the point of contact between the string and the block M. The line of action for the tension force is an oblique line, and its direction is upward to the right. Its magnitude is given, which is equal to the magnitude of the force done by the string on the block, which is equal to 12.5 Newton. The normal force. The point of application of the normal force, as mentioned before, is the center of contact between the block and the plane, which is this point in here. This is the center of contact between the block and the plane. The line of action of the normal force is an oblique line. Its upward to the left is its direction, and its magnitude is mentioned in the figure, which is equal to 21.6 Newton, since it's equal to the force done by the plane on the block. Represent without scaling the forces acting on M. When we want to draw the three forces, first one, the weight force, is drawn from the center of gravity of the block M vertically downward. The normal force is drawn from the center of contact between the block and the inclined plane, like this. The most important condition for any normal force, it must always be perpendicular to the plane. The tension force is drawn from the point of contact between the block and the string along the rope we have. Find the mass of M. To find the mass of the block M, we must use the rule of the weight force, which is equal to weight equal mass times gravity. The mass is then equal to weight divided by the gravity. The weight is equal to 25 Newton and the gravity is given equal to 10 Newton per kilogram. Thus, the mass will be equal to 2.5 kilogram, its SI unit.